This is Avid Research. Today, we're looking at speedy astronomy and we're asking, how do we detect and analyse deep space radio bursts?
Radio telescopes around the world are always listening to the skies, and sometimes they'll detect a fast radio burst. These bursts are about a millisecond in length, and we don't know exactly where they come from.
What do we know about it when a radio telescope detects a burst?
The radio telescope detection can be used to create a wavelength versus time graph. The shape of the sweep of the graph tells us about how far away this event happened. Because light at different wavelengths move at different speeds when moving through material. The more material this radio light traversed, the steeper the shape of the sweep in the wavelength versus time graph. Very important to note that the change in light speed only happens when light is traveling through material. The speed of light is the same and a universal constant for all wavelengths when it's traveling through a vacuum.
So, can't we figure out where the burst came from, since we know where it is based on its position in the sky and the distance?
Yeah, you're absolutely right. If we had an accurate position on the sky, then yes. However, the radio telescope only tells us very roughly the direction that the burst came from. This means there are thousands of galaxies that this burst could have potentially come from.
Okay, so if the position in the sky isn't accurate, then how are we ever going to know where the burst came from?
For some bursts, sadly, we will never know. However, for certain fast radio burst sources, they will burst again. We call those fast radio bursts repeaters. For repeating fast radio bursts, if we can see it a few times, and with radio telescopes that provide a more precise position on the sky, then we can figure out the galaxy that hosts the fast radio burst.
Okay, so now we've detected a strange, unexplained, repeating fast radio burst. People are going to get curious, and curious people are more likely to give us more telescope time.
Yes, that's right. More radio telescope time will allow us to detect the repeat bursts and allow us to get a better accuracy on the position in the sky of the burst. This allows us to narrow down the potential number of galaxies the fast radio burst could be living in.
Okay, so now we've narrowed it down to 1 or 2 galaxies. It sounds like we're still going to need some more detail.
Yes, what would be super cool is if we can detect the burst not just with a radio telescope, but also with gamma ray, X-ray, visible wavelength, and infrared telescopes too. This extra information can tell us about the burst mechanism.
Still sounds like it's a bit of a mystery what these events are, though.
Yes, excitingly, you are right. There's a lot of theories, including that these fast radio bursts are explosions, or maybe neutron stars colliding into other things, magnetars, which are neutron stars with really strong magnetic fields, or even black holes. It's only quite recently that we found out about these fast radio bursts, only about 10 years. So we need to keep looking and listening to learn more and understand them.
So gradually, we're learning more and more, and we're slowly filling in these knowledge gaps, which is always awesome.
It is, and it means we can ask even better questions and learn more and more about our universe.
Thanks so much for tuning in. If you enjoy this video, you're an awesome human, and you should click like and subscribe. You can also check out the awesome Avid Research interview with Dr. Jeilai, where she talks about her really fascinating astronomy career through the link below.